Hello, students. Math connections out of section 14.2. And 14.2 has 2, 3, 7, 10, and 11. So a total of 5. That's not too bad. So we'll start with question 2. When a billiard ball bounces off the side of a pool table, assume the angle of incidence is congruent to the angle of reflection. We talked about that. The only time it won't be, and to be perfectly honest, if you play a lot of pool, if you put a lot of spin on the ball, then it may not be the case. But we're assuming the ball is traveling in a straight line. You hit the center of the ball. How does that come off? In the following figure, showing a scale drawing of a billiard table, a cue ball is at point A. Very interesting. Show how a player should aim to hit two sides of the table and then hit the ball at B. So you want to hit two sides of the table and then hit the ball at B. Well, I'll give you a couple of hints, and you're welcome as well to try this on GeoGebra, which is kind of a cool one to do. You can also do it on paper if you want to, but then you probably need either patty paper or your compass and straight edge. That's up to you. So if I just want to hit ball A into B, I just line it up and I hit, and there it is. I hit the ball. It didn't bounce off anything. If I want it to bounce off one side, pick the side. So as an example, let's say that I pick that I want it to bounce off the right-hand side. Okay. Then I want my ball to hit somewhere over here so that it bounces off and goes towards B. But what do I know? The angle of incidence is the same as angle of reflection. So what I actually do is I take point A and I reflect it across this line, so that this length and this length are exactly the same. Then I can draw a line from A prime up to B. That was horribly done. Let me try that one more time with the straight line tool. Scott, that was really bad. Okay, there we go. What it does is it creates the line, and it also shows me exactly where I want to aim. I want to aim at this point right here. So aim A to hit here, so it will bounce off and hit B perfectly. That is how you get it to bounce off one side. It asks you to hit two sides of the table, and as a huge, huge, huge thing, pick your sides. And yeah, you're probably going to have some reflections coming in. Okay. Why would that be necessary? Occasionally, like we just saw, we'd want to hit it, up in here and it would bounce off and hit. The reason why you can't always do that is there's times where maybe there is a ball, another ball that's blocking your path. And in certain games of pool or billiards, you can't hit another ball before you hit this ball. It's, for example, the game of 9-ball, you have your cue ball here and you have to hit the next ball in numeric order. So maybe this is the 2 ball right here, but this one right here is the 5 ball. You can't hit the 5 before you hit the 2. Okay. And just for argument's sake, we'll say, why didn't you just go straight across? Well, we'll just put a ball right here. Maybe we'll say this is the 7 ball is blocking the direct path. The 5 ball is blocking the bounce off of one wall. So I might have to bounce off of 2 walls to make this happen. Oh, math is awesome. If you ever watch some folks who are some folks, they have so much experience with this that they just, they kind of already kind of see where they need to hit. But when you're looking, this is kind of the fun part. When you're looking from point A, you can kind of, and you'll see sometimes people will lay their pool cue across the table. What they're doing is they're looking for where is the reflection of this ball, right? Where is the reflection of that ball? Because somewhere out here is where that ball would be if I reflected it across the table. And so they look for that reflection. Where is B, right? This piece to that piece. And they say, where is it? And that tells them where to hit along the rail to come back and hit the ball. Okay. Cool question. Man, love these questions. All right, 2, then 3, then 7. So question 3, we have midpoints of the sides shown. We have intersection of the altitudes. D and E are the points of intersection with the perpendiculars from M and N. Okay. And it says, y is A prime the reflection of A and MN? Y is A prime the reflection of C and MD? So again, looking at the reflection of these and looking for similar distances. And then explain why these angles are the same. What property of angles in the triangle follows from this part? You might be able to see, at least I hope you're able to see at this point, that the angle you find right here turns out to be the same as the angle you find right there. And that the angle you started with up on top turns out to be the same as this angle down over here under a reflection. And finally, the angle you had here under a reflection of NE becomes the angle that you have right here. And so if you think about it here, right here, a red, a blue, and a green add up to a certain number, and that tells you a property of triangles. And this was done only with rotations, reflections, and so on. So very cool. Trying to get you to see the property through a different approach. Number 7, I'm going to skip forward here. There we go. Number 7. It's a miniature golf course. You have to get the ball in the hole. Okay, so that means if you've never played miniature golf, you have to hit the ball in the hole. Now, you would want to go straight through. The problem is there's a wall in the way, so you can't do that, which means you're going to have to bounce it off of a wall and get it into the hole. If you can, perhaps it's possible to bounce off the bottom and have it go up and in. I'm not sure. I wish I knew. Perhaps it's possible for you to bounce off of another wall, maybe over here, and it bounces off and goes in. Again, I wish I knew, but you have to bounce off one wall only. And then, how would you do it if you had to bounce off 2 walls? Where would you hit, and why does that make it work? Love it. If you thought the pool one was awesome, this one is even better. Question number 7, a true winner in my mind. And we'll go to 10 and 11 as the last 2. Student says, I have a point and its image. Is that enough to determine whether the image was a translation, reflection, rotation, or glide reflection? So basically, if you tell me, here's what I started with, and here's what I ended with, is that enough? Okay, that's question 10. And you can say yes or no. Make sure you can justify it. Maybe it works for a translation, but not a rotation. Maybe it works for a reflection, but not a glide reflection. You got to tell me if I know a point, a single point, and the image, which is a single point. Is that enough? Question 11, another student here's what's going on and says, oh, wait a minute. What if I have a segment and I have the image of the segment? Is that enough to tell you, yes, I know this was a translation, a reflection, or rotation? Is it enough? Big questions right there, 10 and 11. All right, I think that's about it. That ends this section. So no additional questions, no MCs. If you have others, please let me know. I can make a video for you. I can meet you on campus. I can meet you online, in person, wherever, whenever. Let me know how I can support you. All right, off you go.